in this lesson, we're going to be looking at Ohm's law. Okay, and also, and this equation here. Okay, so if I go back to my examples in my previous video, okay, which was how voltage and current behaves in series and parallel circuits, I want to work out the resistance of this lamp. Okay, now if I put an ammeter in this circuit and I say it reads 2 amps, so I equals 2 amps and I know the voltage is 3 volts. I'm now going to use this formula, okay, V equals I times R to give me R. So how do I use it? I cover up my R, so I'm left with V divided by I. Okay, so R equals V divided by I, which is 3 volts divided by 2 amps, which gives me 0.5 ohms. Okay? Sorry, 1.5 ohms. Okay? So we've basically now put this equation into practice. So this is how we work out resistance. And it's always going to be the case. And just be prepared for examples in your test where sometimes they could give you the resistance of the lamp and the current passing through it, and they will ask you to work out the voltage. And how would you do that? Well, you would cover up V and you would use the value of the current given to you in the question times the resistance of that bulb. Okay? And vice versa, they could ask you to work out current. Then it would be V divided by R. Okay? So that's that equation. But that equation links us to what Ohm's law is. Okay? So if I did a graph of, let's say, voltage on the y-axis and I did current on the x-axis, okay? And I did some sort of experiment, okay? Draw a circuit of the experiment I did. I've got a variable resistor, okay? And I've got a lamp here, and I've got an ammeter, and I've got my voltmeter here. Okay? And how does this experiment work? Well, basically, at constant temperature, what am I going to do? I am going to change the settings of the variable resistor, and I'm going to go from a low resistance to a high resistance. Okay? And each time I do that, I'm going to measure what the current is, and I'm going to measure what the voltage is. And if I did that experiment, basically what you would find, okay, if this lamp was ohmic, you would find that the voltage was proportional to the current. So what does proportional mean? It means if the current goes up by 2, the voltage goes up by 2. Okay? If the current triples, the voltage triples. Okay? So we would say that this lamp or resistor, or whatever that component is ohmic. Okay? And this is Ohm's law. Okay? Voltage is proportional to current, provided that the temperature is constant. Okay? Now, I'm going to use this graph, but I'm going to just change the axes. I'm going to put current on the y-axis, and I'm going to put voltage or potential difference on the x-axis. Okay? I'm going to give you 3 lines. Okay? Lines A, B, and C. And they're going to represent 3 different resistors. Now, using your idea of, or your understanding of vibrations of particles when an object gets hot, okay, and imagine here's a cross-section of some rectangular object, yeah, and here are the particles. Let's say at 0 degrees Celsius, okay, they're vibrating somewhat, okay? However, let's say at 50 degrees Celsius, they're more aggressive, okay, or got more energy, thermal energy, and they vibrate more, okay? I want you to use now this knowledge or this model of particles vibrating at at greater temperatures to help you identify which one of these resistors, okay, link up to which one of these lines. Which one of these lines, which the resistors link up to these temperatures. Okay, current is the y-axis and voltage is the x-axis. Okay, but I want you to focus on current mainly. Okay, you can pause the video, have a think about it, but let's think about this. Line C, or resistor C, has got a low current at this particular voltage. Line B has got a moderate amount of current at that particular voltage, and line A has got a huge amount of current at this particular voltage. So, using our model, okay, of vibrations vibrating more at greater temperatures, I think that minus 20 has to go with that resistor, okay, because we've got a high current. Okay, and it's, by the way, all of these are ohmic resistors, okay, because they're straight lines, so they're proportional to each other. Okay, that's got to be minus 20, and this has got to be 50, and that's got to be 80. Okay, the 80 degrees Celsius, you've got a lot of vibrations happening, therefore it doesn't matter if it was ohmic, you would still have a very low current. Okay. So these type of diagrams, you need to be able to identify, what temperatures each resistor could be linked with. Okay.